So this video is all about acid-base reactions and how we can use stoichiometric calculations within that. We're first going to look at this chart here, which is in your notes. It's a chart on acid-base indicators, and there's, as you can see, a lot of them on here. We've got 5 different really common indicators that we use, and the thing with an indicator is that it's always a substance that will change color depending on the pH. So if it's an acid, it'll be one color. If it's a base, it'll be another color. So that's really important when we're doing a laboratory experiment with acids and bases. So when we do our lab with our titration, what you guys are going to see is exactly this. And if you have, say for example, phenolphthalein, right here, phenolphthalein, you can see that it's colorless in acid, but it would turn pink as soon as it becomes a base. So that's kind of important. So the most common ones that you guys need to know of are phenolphthalein here, and litmus paper we use quite a bit in our course, okay? You might see some of the others when you take grade 12. So an acid-base neutralization. What I want you to do is remember back in Unit 2 we looked at double displacement reactions. And a neutralization is a type of double displacement reaction. So it's when you have an acid plus a base, and it always gives you an ionic salt or an ionic compound and water. So the example I gave you here is HCl. That's aqueous, that's my acid. KOH is my base because it makes hydroxide ions. And when I do the double displacement reaction, this is my positive ion, my K plus is positive, my Cl is negative, and my OH is negative. So if I swap my positives, then the H plus is now going to bond to OH and make H2O. Over here, and my KCl is going to bond to the KCl is formed using the K plus and the Cl minus. So that should be a little bit of review. And, oh, sorry. There we go. So now what we're going to do is look at what neutralization is. So it is the exact point at which the number of moles of H3O plus ions equals the moles of OH ions, okay? So remember that C equals N over V, this equation. If we rearrange our equation, we get that moles is C times V. So therefore, when we're doing a reaction, the moles of the acid has to equal the moles of the base. Or more simply, CAVA equals CBVB. So now when we're looking at A, in this case, A means acid, and B means base. Oops, base. Okay, notice it looks exactly the same as the C1V1 equals C2V2 equation, but we use CA and VA to denote the concentration and volume of your acid. We use CB and VB to denote your concentration and volume of the base. So let's do a really quick example with that. So what is a volume of a 0.50 molar HCl that is required to neutralize 10 mils of a 1.0 molar NaOH? So my answer is there. So if I'm going to use CAVA equals BVB, then in this case, my concentration of my acid is 0.50 molar. My VA is what I'm trying to find. My CB, is 1.0 molar. And my VB is 10 milliliters, but I change that to liters. So when I rearrange my equation, my VA ends up being 0.020 liters, which is the answer that I got up there. So it's a really easy formula. The only tricky part comes in when it's not a 1-to-1 ratio. So we're going to flip to the next, and I'm going to show you how it can get a little bit more complicated. So look at this neutralization reaction between sulfuric acid and sodium hydroxide. So when I balance this equation out, so I've got my acid plus my base, gives me water and a salt. When I balance it out, you'll see that I've got some 2's here in blue, okay? Because I need 2 moles of NaOH for every 1 mole of acid. Why is that? Well, basically, when H2SO4 dissociates, it makes 2 H plus ions. So this is what the dissociation equation looks like. So you can see my 2 H pluses here. become 2H plus on this side, and I've got one sulfate on this side and one sulfate on that side. So now that's balanced. But NaOH only produces one hydroxide ion. So that means in order for these two compounds to react, I need two NaOHs for every H2SO4. So this is not a one-to-one ratio like we have seen previously. So we need to adjust our neutralization equation accordingly. So in your notes, you need to write down our next equation, which is A times CAVA equals B times CVB. And A is the number of H plus ions produced when the acid dissociates, and B is the number of OH ions produced when the base dissociates. So here are some examples here. If you want to copy these down into your book, you can. HCl, when HCl dissociates, I've got one H and one Cl, so my A value is 1. When H2SO4 dissociates, I've got two hydrogens, so my A value is 2. And here's phosphoric acid, H3PO4, so A is 3. And then similar thing with bases, but I'm looking at the hydroxide ions for a base. So here NaOH has 1 hydroxide ions, and therefore my B value is 1. Calcium hydroxide has 2 because of this subscript here. So that gives me a B value of 2. And aluminum hydroxide has 3 as a subscript here, which means I've got 3 hydroxide ions, and my B value becomes 3. So now knowing this new equation, up here, we're going to use that to solve a more complicated neutralization equation. So here, what volume of 1.5 molar H2SO4 is required to neutralize 45 mils of 6.6 molar NaOH? So in this case, I have to write out my balanced chemical equation. And I gave this to you on the last slide, but I'm just going to rewrite it here. So H2SO4 plus NaOH gives me Na2SO4 plus H2O. And to balance it out, I need to put a 2 in front of my Na there and a 2 in front of my H2O. If you want to, you could actually use stoichiometry to solve this problem, but our fancy equation ACAVA equals BCBVB is a lot nicer and easier to use. So for my acid, how many hydrogens do I have? I have 2. So my A value is going to be 2. So I'll put 2 in there. My concentration of my acid is 1.5 molar, right? That's written up here. And that's asking me for what volume of acid. So that's VA, that's my unknown. Now if I look at my base, you know what, I'm just going to color code this a little bit for you guys. Hopefully that'll help you. So my B value here is 1 because I have 1 hydroxide ion in every sodium hydroxide ion. So I get 1 times my concentration of my base, which is 0.06 molar from over here. And my volume of the base is 45 mils. And again, make sure you change it to liters whenever you're doing this. I rearrange my formula and I get my answer that VA is actually 0.0090 liters. So when I round that here, I changed it into milliliters. So 9.0 milliliters with 2 significant digits. All right, so that's pretty much it for neutralization equations. I do have a couple of more examples here. So here's another example. If you guys want to try this on your own, we can use this as a check your understanding. See if you can get my answer of 1.63 molar for this question here that's already in your notes. And then the last one is, again, I have that answer for you of 38 milliliters. So if you want to copy down the answer and then try these on your own, we will take both of those up in class.